It is considered the most recognized certification in the world, probably the most sought after by employers. Over 1 million certified holders across every country that you can probably think of, from Timbuktu, New York, all the way to South Africa. So what certification are we talking about? We're talking about the mighty CCNA. Hey friends, welcome back to this channel. My goal is to be a resource for those that are starting their career in the networking industry through tutorials, course reviews, tips and guides, just like this one. So if you're new here, welcome. I guess this certification needs no introduction. If you haven't heard about CCNA, I don't know which rock you're living under. Now, I want to make a disclaimer. My goal for this video is not to try and convince you whether this certification is good for you or not. The goal of this video is to try and distill the information that is covered in CCNA, in the exam objectives, and probably just go a bit deeper as to what is contained in these topics so that you are able to make an informed decision. Now, I have to say that I might get too excited and it might seem like I'm promoting the course. That's not my objective. I just want you to have enough information to be able to make a decision. So without taking too much of your time, let us begin. So today I decided to do something different. I decided to write down the exam objectives because there's quite a lot of information and I felt like if I tried to keep the information in my mind, I might forget and I might be a disservice to you. So the CCNA exam, I'm talking about the 200-301, this is the latest at the recording of this video, is broken down into 6 domains. But before we get into the domains, if you have never heard about CCNA and you're not so sure what is covered in the course, this is a networking certification that is offered by Cisco, being the vendor. The whole objective is introducing you to 2 of Cisco's core infrastructure devices, the router and the switch. And from a Cisco perspective, this is deemed their entry-level certification. So if you're contemplating starting a career in networking, you are likely going to pass through the certification because it is the golden standard for networking certifications. So now you know that it is targeted towards a career in networking. Now let's break down what is contained in the exam objectives. 20% is network fundamentals. Remember, in the previous video, we spoke about the CompTIA Network Plus certification. And we said that it is vendor neutral and it gives you the basic network fundamentals. One thing that has made CCNA the gold standard that it is, it's because before they start feeding you information about Cisco and Cisco infrastructure, they teach you generic information about network fundamentals. So in this module, you will look at what is a router. Unfortunately, I couldn't find my router to be able to show you what a router looks like, but I've got a switch and I'm probably going to come out of frame so that you can probably see it. Right, so this is a Cisco switch, probably one for small offices and home office. In the corporate space, the ports density is probably going to be bigger, 2448 port, but this is the Cisco switch. So in the network fundamentals, they're going to tell you the devices and how they function. You look at the next generation firewalls. They differ from the standard firewalls because most firewalls started from the layer 4 of the OSI going down, but next generation firewalls go up to layer 7, which allows you things like URL web filtering, which was not available in the normal firewalls. You look at DNAC, which is the Cisco DNA appliance that is used to manage the Cisco's SDA platform. I'm probably going to speak more on DNAC when you look at automation and programmability. So the objective of the network fundamentals is just to give you a broad range of what are the network devices, what role do they play, and how do they act. Now, when you've gone through the appliances, one of the key topics in this network fundamentals is network topology. When you're looking at topology, we are looking at, from a bird's eye view, what does your network look like? And the 3 common topology system that you're probably going to look at is the collapsed core, also known as the two-tier system. This is where you've got your core network, and then you've got your distribution, and then all your devices and endpoints will plug in to that distribution. This is in contrast to the three-tier system, which has got a core, a distribution, and an access layer where endpoints then basically connect. And then in the data center environment, they use something known as spine and leaf. So that is going to be covered in network fundamentals. Then the next domain is network access. Now I need to pause a little bit, because in this domain, you're going to look at VLANs, which are known as the virtual local area networks. You probably heard about VLANs. This is a networking construct that allows us to logically segment our switch regardless of the physical device. Very important concept, very interesting one, but I'm tempted to teach on this, but I'm not going to teach. I'm just going to pass through just so that you can make a decision on what works best for you. So VLANs, you're going to talk about VLANs. You're going to learn about access ports. What is an access port? What does it do? How many VLANs can it carry? You're going to look at trunk ports. This is a port that can carry multiple VLANs. What do we mean by carrying multiple VLANs? You look at 802.1q, which is the protocol that is used to build trunks between two switches to provide connectivity. And then you look at LACP, which is the link aggregation protocol. I'm probably going to delve this into more detail. So you've got two switches that are connected on your network. Now, if you've got one link, there's a problem. If this link went down, and then you lose connectivity between your two switches. So in order to provide redundancy, what they then did is that they added multiple links. But the problem is that there's something known as spanning tree that we're probably going to talk about, which blocks redundant parts on a network to prevent loops taking place. So in order to circumvent that, they brought in LACP, which allows us to bundle those links and logically appear as one physical link. Fascinating concept. So you'll notice that when I speak most of these topics, I'm probably going to try and define what the problem was and what it is that the technology is basically trying to fix. I get excited. Maybe I might not show it in my face, but I get excited when I talk about CCNA stuff, because this is a very dear course to me. Dear in the fact that I've taught it, I've studied it, and I use it on a day-to-day basis. But let's not digress because of my excitement. Let's go ahead. Spanning tree. This is a phenomenal concept. Phenomenal in the fact that almost 50%, that's according to me, of network outages are as a result of spanning tree. And if you haven't encountered a P1 outage as a result of spanning tree, you haven't started living in the network world. Ask people who have been in the networking industry for quite a long time. They will tell you spanning tree is going to burn you at some point. It's a matter of time. It's a matter of if, not when. It's a matter of when, not if. Yes, it's a matter of when, not if. It's probably going to burn you. I cannot count how many times spanning tree has caused major outages on networks. So it's a concept that you want to learn. So what is spanning tree and what does it try and do and what is it trying to solve? So I want you to imagine you've got three switches on our network. 1, 2. In order to provide redundancy, we connect these three switches together. Now the problem is that we've created a loop because traffic can be sent here, forwarded here, and then forwarded back, creating a loop on a network which creates a problem. So what spanning tree basically came and did was it blocks one of these links to prevent a loop from taking place. When it works, it's fantastic. When it doesn't work and a loop occurs, the resources on your switch infrastructure are going to be maxed out, and all of a sudden you're going to start dropping traffic, creating a problem. So very, very, very important topic for you to learn. So in spanning tree, in order to prevent these loops, there are concepts known as a root bridge. So spanning tree has to elect a root bridge that controls the whole spanning tree protocol. Once again, tempted not to teach, but just to give you information. So now you learn about spanning tree, you're going to learn about the wireless components. What makes up a wireless network? You got the wireless LAN controller. What is it? How does it control? Is it a control plane device? Is it a management plane device? You got the access points. You learn the different types of access points and how they communicate with the WLC, and in turn how they broadcast the wireless network to the rest of the devices on the network. So that's what is covered in the network access layer. When you come to IP connectivity, our focus now is about routing traffic from point A to point B, or from source to destination. You look at interior gateway protocols. These are the protocols that enable the sharing of routes over the network, and the common routing protocols that you're going to come across are RIP, EIGRP, OSPF. These are interior gateway protocols. And for the wide area network, we've got BGP, which is the internet protocol. BGP basically runs the world. And then in addition, you're going to look at administrative distance. Administrative distance simply says, if I've got an OSPF route and I've got an EIGRP route, which one should I trust? In real life, you're probably looking at CNN versus Fox News. If you hear the same news that O.J. Simpson died, which one do you trust, Fox or CNN? Whichever of the two you're going to trust means that the priority for you is lower. In networking, the lower the AD, the better the route. And then you look at static routes. What is the static route? Why do you need it? What problem does it solve? Now, I want you to take a step back and think. You are driving out of town and you're going into a country location. In Australia, we've got so many deserts. So if you're probably going to be driving into desert territory, you want to make sure that you're prepared. And you're likely going to encounter certain locations or areas that don't have network coverage. So if you're going to be relying on your IGP protocols, which is your GPS, to give you directions, when you get to an area where there's no network coverage, your GPS won't be able to function. So sometimes you need a static route, which means that you need a physical map that maps how you're going to get from point A to point B, so that when you get to areas where there's no GPS, you don't need to be relying on the network coverage. That's the best example that I can give you as of a day-to-day basis example. So you learn about static routes, how you configure them. You learn about first hop redundancy protocols such as HSRP and VVRP. So by just looking at the first three, you can probably realize that this course is not your standard entry-level course. This is not your basic entry-level course. This course goes deep. And because it goes deep, most people find it challenging because they are coming in expecting this level of depth, and they find this level of depth. CCNA is usually offered over 2 textbooks, right? In the old textbooks, in the old syllabus, they used to call them ICND 1 and ICND 2. And in the new syllabus, it's now called Volume 1 and Volume 2. Now, these textbooks are probably 900 pages each, right? So you're looking at about 1,800 pages. But anyway, back to the board. So now we know about IP connectivity. Now we're going to be looking at IP services. IP services focuses on protocols such as NTP, which is the Network Time Protocol, a very important protocol that controls and gives time to our devices, which affects things such as certificates, which are time-oriented. If time is incorrect, your certificate's validity is probably going to be out of sync and devices will stop authenticating. So you need constant time. NTP does that. Then you've got DHCP, which is the Dynamic Host Configuration Protocol. This is the protocol that issues out IP addresses automatically. If we didn't have DHCP, connecting to networks will probably be a pain. And then you're going to be looking at QoS, which is my favorite, one of my favorite topics, quality of service. How do you prioritize traffic on a network? And then you look at SSH and SNMP. So that is what is covered under IP services. And then the last two look at security fundamentals. We can't ignore the fact that we need security on our networks. Security is very important. Why? Because we live in a world where people are trying to break through into our networks, eavesdrop, collect sensitive information. I cannot probably count the number of organizations that have been hacked in the last 12 to 24 months. You probably know whichever region in the world you're in, there is probably something in the news almost on a daily basis. So we need to know, how do we protect our networks from threats and the vulnerabilities? But also in security fundamentals, you're going to look at how do you control access onto your network. I'm not so sure, but at some point in your life, you've been to a wedding, and that wedding had a guest list, and the guest list controlled who got into the wedding or not. If your name was on the list, you could go in. If your name is not on the list, you can't go in. In networking, we've got something known as access lists, which basically control traffic as it goes through your network. So on a router, you'll have an access list applied on traffic that is coming inbound. And depending on whether you're permitted or not, you're going to be allowed to be able to proceed or not proceed going into the network. So that's a very important concept that controls the flow of traffic on our networks. Then you're going to look at the famous VPNs, virtual private network. What is it? A VPN in simple terms is a virtual private tunnel that allows you to use an untrusted network such as the internet to carry information but encrypted, so that if someone was to eavesdrop on that conversation, it's encrypted, there's nothing that they can do about it. So VPNs are a very important construct. So you learn about encryption algorithms that are basically used to encrypt the traffic. You learn about the different types of VPNs. You got remote access VPNs, you got site-to-site VPNs. How do they differ? How do they work? And then last off, you're probably going to close off by looking at automation and programmability. Cisco has seen a shift in its technology in the last 5 years. They are moving from what is known as the command line interface, where most of us basically learned our networking. You know, you got a black screen and you're basically typing commands. Cisco said, nah, this is not going to work. They want a way that you can be able to centrally manage your infrastructure instead of connecting to each and every device individually. So they brought in automation and programmability to be able to then control that. In order to do that, they brought in, remember I spoke about DNA Center or DNAC. So DNAC is used to control your software-defined access, being the control, the management plane that interacts with the devices on your network, and you can configure that via a graphical user interface as compared to your command line. But in order for that to work, Cisco had to change its architecture. So now you've got terms such as overlay and underlay. And when you're talking about underlay, we're basically talking about the foundation onto which your overlay runs on. Now you're probably saying, Tinay, that doesn't make sense. So what example can we give? I'm standing here on the carpet, but the carpet sits on the floor, which sits on the foundation. So the foundation and the floor are basically the underlay, because they are the ones that are holding my carpet. And the carpet is the overlay, which then makes things comfortable. So the underlay is the connectivity of devices on your network, which allow you to be able to reach point A to point B. And then overlay is then your tunnels that then allow you to then utilize the underlay to communicate with devices. So when you do CCNA, you cover that into detail. I probably can't go too much into it. And then the famous REST APIs are also covered in this particular section. So these are the 6 domains for CCNA. I've basically just scraped the surface. I haven't even covered much in detail, but you can probably see the amount of depth. But this is the summarized version to help you make a decision. So who is this course targeted towards? It's targeted towards people who want to become network engineers. Right, so if you want to become a network engineer, you know, CCNA is probably a very good certification to be able to go through. Yeah, you can be a network administrator. You can be a junior network engineer. If you're going to do a CCNA, these are probably the 2 target areas that you want to be able to focus on. In terms of demand, this is the #1 demanded course in IT. Every organization that's probably going to be looking for someone who's a network engineer, there's a 90% chance that they're looking for CCNA, because it is the gold standard, it is the gold measurement. When you say you got CCNA, these are the things that you're expected to know. In subsequent videos, we're probably going to dive down into comparing CCNA with other certifications. We're probably going to be looking at the job market, how much you can basically get paid. I'll probably summarize how much you can probably get paid in Australia, You can get up to 100,000 with your CCNA, maybe more than that, but your experience is probably going to count more towards. In the UK, 30 to 40,000 pounds a year. In the US, 100,000 plus. Once again, most of this is going to be dependent on your experience rather than the certification all by itself. So if you've got any questions, you can let me know in the show notes or in the description below. Just hit me up and I'll be able to answer. But I hope now you've got a much better understanding of CCNA as a certification and what is covered in this course. If you made it to the end of this video, I just want to take time to say thank you for making it this far. If you've got any questions, let me know in the comment section and I'll be able to answer them. Once again, thank you for watching and I'll see you in the next one.